Hi guys, this is Mrs. Denton. Today we're going to do lesson 7-1, scatter plots. Grab you some notebook paper. Let's get started. Your warm-up says plot the point in a coordinate plane. You've got 6 points to plot here in this coordinate plane. Pause the video, see how you do, and come back here in a second and we'll check your work. Okay, let's look at number 1. Number 1 has 1, 6. If you'll recall, we have our x, then our y when we're working with an ordered pair. So look at our x-axis, our y-axis. 1, 6 is going to move over on the x-axis 1 point and up 6 points on the y-axis. So if we go over 1 and up 6, we've got a point right there, and we can label it if we need to, 1, 6 inside parentheses separated by a comma. Number 2, 4, 3, we're going to go over 4 units, up 3 units. There's our location for the ordered pair 4, 3. Number 3, 0, 4. So our x-coordinate is 0. Our y-coordinate would be where we cross the y-axis at. So we're going to stay in the center on our x-axis, and we're going to go up 4 units on our y-axis. Number 4, 5, 2. We're going to go over 5, up 2. Ordered pair 5, 2. Number 5, 3, 3. Over 3 on our x, up 3 on our y. Ordered pair 3, 3. And number 6, 5, 0. When our y is 0, it means it crosses the x-axis at 5. So we are going to go over 5 units. Our y is equal to 0, so we're not going to move up or down. This ordered pair will be on the x-axis. There you go. Okay, we've got a vocab term here, scatter plot. Scatter plot is a graph that shows the relationship between two data sets. So we're talking about a relationship again. Remember yesterday in our intro to scatter plots, we referred to that relationship in math as a correlation. Now these two data sets are going to be our x and our y. In the first example, you can see this scatter plot is going up from left to right. That means our x is increasing, our y is increasing as well. That would be a positive correlation. In the second graph, we've got points scattered about. There is no pattern. That we call is no correlation. There's no relationship going on between that x and y variable. In the third example, you can see it's decreasing from left to right. That's when one variable is increasing, the other is decreasing. That is a negative correlation. Okay, example 1. The scatter plot at the left shows the amounts of fat in grams and the numbers of calories in 12 restaurant sandwiches. You can look at the scatter plot. Title is restaurant sandwiches. Your x variable is fat in grams, and your y variable is the calories. Part A says, how many calories are in the sandwich that contains 17 grams of fat? Now we can come over to the scatter plot, and we're given 17 grams of fat. We do not know how many calories there are. So if I find 17 grams of fat, which is approximately right there, and I want to know how many calories, I'm going to basically create a line and follow it up to that point. And then I can look over at the x-axis and I can see that that is approximately 400 calories. So how many calories are in the sandwich that contains 17 grams of fat? The sandwich has 400 calories. Part B, how many grams of fat are in the sandwich that contains 600 calories? Now this one is giving us the calories, asking us how many grams of fat. So we're going to reverse what we just did. Now we're going to find 600 under the calories and we're going to follow it out. And we can see that we meet a point at exactly 30 grams of fat. So we are going to say the sandwich has 30 grams of fat. Okay, part C. What tends to happen to the number of calories as the number of grams of fat increases? So if we're looking at our x-axis as we move from left to right, as the number of grams of fat increases, what is going on to the number of calories? So if you look at the graph, as x is increasing, what is y also doing? Y is increasing as well. So we can make the statement as the number fat grams increases, the calories also increases. So as our x is increasing, our y is also increasing. That's why we have an example of a positive correlation. Both variables are increasing. Okay, our next slide here has some information reviewing the types of scatter plots. So again, a scatter plot can show that a relationship exists between two data sets. The first example shows a positive linear relationship. It's increasing from left to right. As x increases, y also increases. The next one has a negative linear relationship, and you can see it's decreasing from left to right. As x increases, y decreases. Our third example shows a non-linear relationship. Remember, non means there's not a line. The points lie in the shape of a curve. And the last one, we have no predictable pattern, no relationship, or no correlation. Okay, example 2. Describe the relationship between the data, identify any gaps or clusters. Okay, let's look at these two tables. Let's just look at example A. Television size and price. So the first part here says describe the relationship between the data. So if we're looking at this scatter plot between our television size and our price, do we see a pattern occurring here? If you look closely, you can see that we have a positive correlation. So as x increases, y is also increasing. So when we describe the relationship between the data, we can say we have a positive linear relationship. That's our first part. And then it says identify any gaps or clusters. So let's look here. Do we have any gaps in our data. It looks like right in there we've got a space. So maybe a gap from 500 to 1500. A gap in the data from 500 to 1500. And cluster. Do you see a bunching or a group here? I see a cluster right in there around the 500 point. So positive linear relationship, semicolon, a gap in the data from 500 to 1500, and a cluster around 500 are in the data. Finish out that sentence there. Okay, let's look at the second one. Example B, age and number of pets owned. So when we start looking at the scatter plot here, there's not a positive trend, there's not a negative trend, they're scattered around, it's variable, it's as X is increasing, we've got some where Y is increasing or some where Y is decreasing. There's no relationship or correlation between age and number of pets owned. So if we're going to describe the relationship between the data, we are going to say no correlation, and any gaps or clusters, when there's no correlation, there are not going to be any obvious gaps or clusters. So we're going to say there are no obvious gaps or clusters in the data. Okay, example 3. Make a scatter plot of the data and describe the relationship between the data. Identify any outliers, gaps, or clusters. So first thing that we're going to do here is make a scatter plot. Then we can go on to describe the relationship and identify any outliers, gaps, or clusters. So when we look at our table, we have our X and our Y. So I'm going to go ahead and label and set up my graph. So my X is study time, my units, minutes, and my Y is going to be test score. Now, one other thing here. When we are talking about this, we want to go ahead and look at intervals. So if I'm looking at my X, I see a range anywhere from 10 up to, looks like 120. So I could go by intervals of 10, and I may not want to label each one of these. If I labeled every other one, 20, 40, 60, 80, 100, and 120. Now, when I'm looking at my test score, obviously I don't have anything lower than a 62. So I might want to make this little symbol here that shows that my y-axis is going to skip through some values. And let's just say we start at 60. And if I want to go up by intervals of 10, but I only want to label every other one to keep it a little clean looking, I don't have to go any further than this right here. So basically I have my intervals set up. Now we're going to go ahead and switch and we're going to graph these ordered pairs. So we're going to think about them like an ordered pair, X and Y, and we're going to put each of these points on the graph. So my first ordered pair would be 30, 80. So I'm going to come over here to 30, and then I'm going to go up to 80 and plot that point. Then I'm going to do 20 and 74. Now we're going to have to be approximate on 74. 60 and 92, so over to 60, up to 92, just a little bit above that. 45 and 85, so over here to 45 is going to be in between an interval and 85. So somewhere approximately right there in the middle. 10 and 62. 30 and 83. Very close there. 75 and 90. 120 and 70. And 80 and 91. Okay, so we've got each of our points plotted here on our graph. Now we're going to describe the relationship, and we can see that it is a positive linear relationship. It's increasing from left to right in the shape of a line. Okay, now we're going to ask ourselves, identify any outliers, gaps, or clusters. Any outliers, gaps, or clusters. Okay, one thing that I noticed, there's not gaps or clusters, but we have a value right over here that's going to be considered an outlier. So when we get ready to label that, we can say no obvious gaps or clusters. And we want to mention we do have an outlier. That outlier is 120, 70. So you can see that one right there as your ordered pair.